Thank you very much. Good morning, Matt, and thanks for having me here. My name is Mate, or today you can call me Mate. I represent Innovatrics. I'm based in Singapore, and today I would like to talk about how we work together with Network Optix, how we integrate our face recognition / video analytics solution with the NX platform. So before we start, just a few words about the company. So Innovatrics is a European-based, an EU-based independent biometric software technology vendor, which means we develop in-house built proprietary software technology for biometrics or biometric matching. We are not only specifically from the face recognition and the video analytics or CCTV background. We are from the biometric background. So this is our core business. We develop large-scale applications for both government and enterprises to identify people or to verify identities in an instant, trusted, and ethical way. This technology, since we've been around for more than 17 years now. The slide says 16, which means this is a one-year-old slide. But yeah, we've been around for more than 17 years. Over those years, our technology and our large-scale applications reached the most of the regions, most of the countries in the world, especially large-scale government deployments. So I keep emphasizing large-scale because this is really our core business. This is our main focus, large-scale biometric applications, not only for face recognition, but including fingerprint recognition, iris recognition, ID document recognition for national registry systems, law enforcement systems, immigration systems, and of course, CCTV, access control, public security, and video analytics. We are a global company. As I mentioned, we are an EU-based company. Our HQ is in Slovakia, in Europe. We are present in most of the regions. I'm in Singapore. I'm based here, taking care of the APAC region. As I mentioned, Innovatrics has many different proprietary technologies for different purposes, for different biometric modalities. But today we are going to talk about one of our solutions called SmartFace, which is our facial recognition platform. We call it a platform because SmartFace as such is not only one specific application for one specific use case or purpose, but SmartFace really is a platform which gives you a lot of different options. So this is a platform which is scalable. It's possible to deploy in a cloud, in an on-prem environment, on an edge device. You can use it with different plugins, different modules for different purposes. We're going to talk about those purposes in more details. But now let's just say SmartFace is a real-time, scalable face recognition and video analytics platform, which is supposed to be used with different or multiple real-time or recorded video streams for different use cases, which we are going to address now. Basically, what SmartFace does is the basic features are actually quite simple. So what we do, we take multiple different video streams, we detect faces, we track those faces, identify those faces in different watch lists, which are configurable, and then we use this basic real-time powerful face recognition platform to apply this technology in different applications, right? What is a differentiator here is that, number one, we are one of the top-ranked face recognition vendors in NIST. NIST is the National Institute for Standards and Technology, a US organization, which is always supposed to be the number one go-to place when you're selecting a face recognition or any kind of biometric technology vendor. This is an independent organization benchmarking all the vendors for face recognition, fingerprint, iris recognition. So if you want to learn about the performance and the accuracy of your face recognition vendor, which you're considering to use, please go to NIST website. They have many different benchmarks. One of them is FRVT, Face Recognition Vendor Test. This has a huge list of more than 300, almost 400 different biometric or face recognition technology vendors with the actual measured accuracy and the performance of the technology. This is really a trusted source of information. It's completely independent. We are constantly top ranked in the NIST FRVT benchmark, which means this technology is right now one of the most accurate and the most powerful face recognition technologies in the world, commercially available. Right? This is a face recognition platform for real-world situations, real-world use cases. So as I mentioned in the previous slides, SmartFace is a platform. It does the job when it comes to face recognition and video analytics in a real-time stream, and this comes along with many different modules. This comes with a complete feature set for any face recognition use case or any common face recognition use case. So we apply that technology, we apply this face recognition algorithm or engine on a specific use case which you need. By default, SmartFace is built for integration, right? So we are a technology vendor. We try to build all our solutions and applications in a way that it's possible for a third party, for a system integrator, or for another software development company to take this solution, deploy in their own way, in their own premises, on their devices, and integrate the technology and the solution into their complete application. It can be a VMS, it can be a time and attendance, or an access control system. It can be a government application for national ID registration. It can be a government solution for immigration or airport security. Basically, what we always try to do, we always try to work with system integrators, so we empower their application, their complete solution with our proprietary biometric technology. Of course, this also means that the technology must be hardware independent, hardware agnostic as much as possible. We try to be very flexible when it comes to different third-party software and hardware components, so everybody can use the technology without any compromises. Okay, so finally, let's talk about the use cases. The use cases or the verticals that we are mostly focusing on are these three: so access control, public security, and video investigation. So let's go one by one, and let's talk about what we actually do for these use cases, how we apply SmartFace and our face recognition technology for these use cases. Access control. Access control is one of the, I would say, pretty much traditional use cases of biometrics or face recognition, but also fingerprint recognition as well, right? So what we do, we use our SmartFace technology in different ways. We can use it in a cloud, we can use it in an embedded device sitting on a turnstile, or we can use it in an on-prem server connected to the device, connected to a turnstile, connected to an office door. What we are able to implement using SmartFace is a very innovative way of access control. We call it seamless access control, which means we use a camera, any camera, or any face recognition device, or any tablet with an embedded, with a built-in camera sitting on the turnstile. And what we do is we capture all the faces, all the people which are in front of the turnstile. We don't start evaluating or processing the face which is standing in front of the turnstile, looking into the camera, waiting for the processing result, and so on. We do the face recognition and the whole processing while this person is walking, while this person is moving towards the turnstile. This is why we can call it seamless access control. This is what makes it seamless, because eventually we implement a completely seamless walk-through or even drive-through in a vehicle lane scenario where these users don't have to stop, because what we do, we use exactly the same face recognition technology, which is used for surveillance which must be very, very powerful, of course, we can use the same power within an edge device or in a cloud for access control, which means we can process multiple faces in real time, in a seamless way. So while I'm walking, my face is being recognized. When I approach the turnstile, when I get close enough, an action is triggered, which is closing the door, opening the door, closing the door. So basically, I don't have to wait. I don't make others wait behind my back. I don't create queues. We can really achieve very high throughput access control solutions using this technology. We will talk about this later, and I also demonstrated how it performs in action. Video investigation is a slightly different vertical. So as I mentioned, our core business, our bread and butter is large-scale solutions for governments and enterprises as well. But now let's focus on governments. Within governments, one of our key focuses is law enforcement. We have multiple huge law enforcement applications in the world, national scale law enforcement applications, not only for face recognition, but with fingerprint and iris recognition as well. But when it comes to face recognition, law enforcement is either taking a photo of an arrested person and searching that photo in a large database, or if this person is not arrested, but they have a recorded video footage from a crime scene as an evidence, we can process this video footage in a very, very fast way. This is one of our key features, rapid video processing, which means we are able to process these videos much faster than the actual duration of the video. We can process it up to 25 times faster, of course, depending on the hardware resources, than the actual duration of the video, which means if we have a 1 hour long video footage and we have to pick up all the faces and identify all the faces in a law enforcement database or in a blacklist database, which appear in this video, this 1 hour long video, depending on the hardware resources, can be processed within, let's say, up to 3 minutes. If we have multiple video footages from a crime scene, from an incident, from different facilities, different cameras, we can do the math, how long it would take to process all those videos. So this is more towards the law enforcement side of the story. And of course, let's not forget to mention the most traditional use case of CCTV or face recognition, which is public security, so surveillance. Just like we pick up faces and identify faces from our recorded video footage, we do exactly the same thing in a real-time video stream or multiple video streams. So detecting faces, identifying faces, tracking those faces, not only faces, but pedestrians, so human bodies as well, even without the face being visible, is supported by SmartFace. And the advantage of this platform, and now let's go back to this keyword platform, is that all these 3 use cases which we mentioned, which is access control and time and attendance, thanks to the open API and the option of the integration and so on. So access control, time and attendance, video analytics, public security, everything is covered by one single platform, which is one single installation, one single deployment instance of SmartFace sitting in your commercial building, let's say, right? You have a huge commercial building with a capacity of 5,000 people. There is one SmartFace instance sitting in an on-prem server in this building, or there's one SmartFace instance sitting in a cloud connected to this commercial building, or there's a distributed deployment of SmartFace on different edge devices, different edge cameras, access control devices, other kind of distributed edge devices, and an on-prem server, or a combined hybrid way. Basically, one instance or one ecosystem of SmartFace is able to handle all these 3 use cases in your commercial building. So when you enter this building, you approach the turnstile, the door opens automatically while you're walking without you looking into the camera, without stopping, without even slowing down. You walk into your office, the elevator is called automatically based on your recognized face. The elevator takes you to your floor without you touching any button, without caring about where you're going, destination control, the elevator, and so on. You enter your office, seamlessly. You just keep walking, the office door opens automatically, while your security personnel is monitoring the building and using face recognition from that same SmartFace instance sitting in the building for public security, surveillance, and the overall monitoring of the building. And if there is any incident in the building which must be investigated, and let's say there was no real-time face recognition for those cameras enabled during the incidents, using the same SmartFace instance, your security personnel or law enforcement can investigate those videos and process those recorded video footages. This is all covered by one single instance of SmartFace, using different modules, different plugins to apply the same core engine, same core face recognition engine to all these different use cases. Besides having different modules, different plugins for different use cases, so for access control, we have an access control plugin which handles turnstiles. For video surveillance and public security, we have an NX plugin, so we integrate the face recognition into a VMS. For video analytics, we have another plugin, and we have a special dashboard and the user interface to investigate those videos with a video player, with a face adjudicator. So it's more focused on law enforcement, right? So besides having these special plugins or modules, SmartFace also comes with a few unique features which make the solution very, very powerful. Of course, as I mentioned, the technology itself, the face recognition and identification technology, is one of the most accurate ones in the world right now, according to NIST. Plus, this is improved, this is still enhanced by some of these unique features, which I would like to show you now. One of these features is called Watchlist Auto Learn. Watchlist Auto Learn is a really, really smart feature, which is very powerful in use cases like time and attendance or access control. This feature is really useful in environments where the same group of people, the same group of users, let's say 5,000, 10,000, whatever number of users, keep showing up in front of some of the cameras on a regular basis. Which means if I have an access control system in my office and I keep coming to this office every single day, I enter the same building every morning, I cross the same turnstile, I enter the same elevator, I enter the same office, the same room. So the same access control cameras keep capturing my face over and over again. It means that we should use this information to learn, right? Instead of registering a person using one photo at the beginning and then just letting the FR engine to use that one photo for years, we enable the FR engine to learn how this person changes over time. I'm also changing over time, right? I arrived to the office today, but next year when I arrive to the office, of course I'm getting older, definitely not younger. I can gain some weight, I can lose some weight, I can get a different haircut. Sometimes I'm wearing sunglasses, sometimes I'm wearing the face mask these days, of course. Sometimes I'm wearing some head covers. When I enter the office, let's not talk about a 1 year long period, but let's just talk about one working day. When I enter the office in the morning, there is very strong sunlight in the lobby, which of course affects the way the camera sees my face. It changes my appearance from the camera's perspective. When I leave the office in the evening, because I'm a workaholic, I leave at 11 p.m. every day. The lobby is really dark. It's a completely different way how the camera and how the FR engine sees my face. So all these factors affect the performance of the face recognition. So what we have to do in order to achieve exceptional accuracy of the face recognition is to keep learning how that person can change over time, within 8 hours, within 24 hours, within a month, within a year, within 5 years, right? What happens in SmartFace when I keep entering the same building is that my face is captured. Of course, my face is matched against my watch list record. And if there's a good quality if this face which was captured in front of the camera, which was spotted by the camera, has a good quality, SmartFace also updates my profile. So it appends this face to my biometric profile. So it keeps learning how my face keeps changing, basically, which means eventually is that the more frequently I use the system, the higher accuracy it will achieve when it comes to my face, because it will learn how my face looks like, looks from a frontal view, from the bottom, from the top, from the side, in sunglasses, in a dark environment, in a very good lighting condition kind of environment, with face mask, without face mask. So the more I use the system, the smarter it gets, the more accurate it gets, thanks to this instant, continuous, automatic learning process. This is exactly how we can achieve exceptional accuracy in very challenging situations as well. Access control, especially seamless access control, when we are trying to improve the user experience by not forcing the user to stop at the door, look into the camera, wait a couple of seconds. We just want this person to keep walking, just texting on their phone, not looking into the camera, not even slowing down. This means the person is not really collaborating, right? It's not really looking into the camera. It makes it much harder to recognize faces. But of course, when we talk about CCTV surveillance and public security, the whole situation is even worse, right? People are trying to cover their faces. They are really not trying to help the system to recognize their faces accurately. Not even talking about the current COVID situation. In most of the countries, people are still wearing masks, especially in interiors, inside buildings. So these face masks also make it much more difficult to recognize faces in an accurate way. But also thanks to the watchlist auto-learn feature in, let's say, in an access control or in an office building scenario where the same people keep showing up over and over again, we also learn how those people look with face mask, without face mask. This also helps to achieve exceptional accuracy when it comes to challenging environment, which means covered faces or partially covered faces, faces captured partially from a side in a dark environment, and so on. The last unique feature, which I'd like to talk about, and I will show you in a couple of minutes in the live demo, is passive liveness detection. Liveness detection as such, we also call it anti-spoofing, or we call it presentation attack detection. So these are the common terms in the industry. It's basically evaluating whether or not the biometric sample, now technically speaking, the biometric sample presented to the system, which in our case is a face photo, is from a real genuine person, or it's some sort of presentation attack. Presentation attack can be a printed photo of somebody shown to the camera, or it can be a tablet screen, a PC screen, or a cell phone screen showing a photo to the camera, or it can be a very high quality 3D mask, which I'm wearing to cover my real face and to pretend to be somebody else. So liveness detection as such makes sure that the person presented to the biometric system is a real person, is not some sort of spoof, it's not some sort of fake. Liveness detection as such is always, or can be, two types, active and passive. Active liveness is something that we use in the biometric industry to force the user to prove their liveness in an active way, which means we give some instructions to the user. In case of face recognition, this instruction can be move your head up and down, blink with your eyes, follow some instructions, and we evaluate whether or not the user is following those randomly given instructions. This is active liveness check. On the other hand, passive liveness check means that the user does not have to perform any action. They don't have to actively try to prove their liveness. They just use the system. I just take a selfie as I would be taking the selfie anyway. I just keep walking in front of the camera and crossing the turnstile as I would be crossing the turnstile anyway, right? So this passive liveness check, of course, is always more challenging because we don't have a collaborative user again. but it always improves the user experience significantly, and it increases the value and increases the quality of the solution. So SmartFace comes with a passive liveness detection algorithm, which means whatever you use SmartFace for, it can be your surveillance system, or it can be your access control and time and attendance system. When we detect a face and identify that face and track that face instantly in a real time, you get all this information along with the liveness evaluation results. So we also tell you whether or not this face is a real face or some sort of fake. Important to mention again, this is a hardware agnostic solution, so you can use any camera. It can be your cell phone, it can be a built-in camera in a tablet or in a special access control device with a screen with a built-in camera sitting on a turnstile, hanging on the wall, or it can be any CCTV camera. Last slide before we move to the live demo, a little bit more from a technical perspective. SmartFace comes in a completely distributed architecture. Face recognition as such, in general, has a few operations, has a few different steps. There is face detection, which is basically exploring a face somewhere in the scene. Once this face is detected, we know there's a human face. There's face tracking, which keeps tracking that face within the scene or across different cameras. And then there is identification or matching, or searching that face in a watch list, in a database. SmartFace has a completely modular architecture where these different operations can be done on different devices deployed in different places, and all these devices, all these modules create the complete SmartFace ecosystem. We support deployment on, and now going from the bottom of the slide, edge devices, which can be edge camera, can be a tablet, can be a cell phone, can be smart glasses, can be another edge device connected to a few cameras. Going higher to the bottom layer, on-prem deployment on on-prem servers, PCs, etc., also supported. And going to the top level, going to cloud or centralized servers, which is also supported. This means that the complete SmartFace ecosystem and every single operation, every single module can be deployed on all these layers. We can run the complete processing pipeline from detection to identification in a standalone mode on an edge device on the bottom layer. We can run the complete whole thing on an on-prem server or on a cloud server, or we can distribute it. Right? We can have face detection and template extraction, let's say, on the edge device. This template or this photo, this cropped face is sent to an on-prem server for identification, or directly to a cloud for identification. Or we can just use the edge device just to send the stream directly to the cloud, and the cloud will do the whole job. So this gives you a lot of flexibility when it comes to deployment. You can have the heavy lifting on the client side, on capturing, or let's say the edge side, or you can have the heavy lifting in the on-prem server or in the cloud, or you can distribute the whole thing. A few case studies which I would like to touch before we start the live demonstration. Let me spend a few more minutes on these slides. I have 3 case studies, so let's try to make it 3 times 1 minute. SmartFace is right now deployed. This is probably one of the most relevant use cases or case studies we have in South Australia. I guess most of our attendees are familiar with this CBS regulation in South Australia, and some other states in Australia have the same initiative for gaming venues or basically any facility with a certain minimum number of gaming slot machines, which have to deploy real-time face recognition solution in their facility for self-exclusion purposes. This is already in place. This is already delivered in multiple different venues in South Australia using SmartFace and NX Witness as the VMS integrated with SmartFace. Smart access control. we work with multiple partners, multiple system integrators in Europe and Singapore as well, which deliver complete smart building ecosystems. So as I described, that user journey with entering the building, crossing the turnstile, entering the elevator, entering my office, using smart access control, seamless access control for all these purposes, using time and attendance, and the same solution, the same platform, or the same instance of SmartFace being used for security, surveillance, video investigation, and so on. So this is being delivered by some of our partners, as I mentioned, in different regions, our system integrators. These buildings are usually large commercial buildings, like 1,000, 5,000, 10,000 plus employees per building, which are handled by SmartFace for all these scenarios, basically, which we've been talking about. Very important to mention that these are GDPR compliant solutions. So GDPR, mostly important in Europe, of course, Australia, New Zealand as well. These are GDPR compliant solutions, so we can fully comply with all these regulations related to privacy. Another interesting usage of the access control solution is deployed in the Middle East. This is a large university campus in the Middle East with more than 30,000 users, employees, and students registered. So basically, the watch list size is more than 30,000. This system integrator, this partner, implemented a seamless walkthrough and drive-through scenario at the entrance of the campus. So as you can see, they deployed not access control devices, but regular CCTV cameras at the vehicle lanes, at the pedestrian lanes, which capture the driver in the car or capture the pedestrian in a seamless way. The point of the solution is that the driver does not have to leave the car. The driver just keeps driving through this vehicle lane. The face is recognized, and if the face is recognized and identified as a person registered and allowed to enter this area, the gate opens automatically. Again, I would like to emphasize that SmartFace is primarily built for system integrators, right? So of course you can deploy it along with some of the out-of-the-box plugins, solutions, integrations, like for example the NX Witness integration. So you can just take SmartFace as is with NX Witness and you're ready to go. But if you're a system integrator and you're willing to develop a custom application, you're welcome to use the SmartFace API. It comes with a complete API. Basically, you can handle the complete solution using this interface as a system integrator. You can control everything within SmartFace. You can create your own solution out of it. So these two solutions, which I showed, the university campus access control and the smart building platform, those are solutions built by a system integrator using SmartFace API, basically. Okay, let's move to a live demonstration of SmartFace. I'm going to switch my screen now. I'm going to switch it to just a second. Are you still there?
Screen hasn't switched across yet. Oh, there we go.
Okay, I hope everybody can see my screen now. This is now my NX Witness VMS running on my laptop, and this is me. Hi there. Can you see me?
Yep, all good.
Cool. So, yeah, so here we go. This is NX Witness along with SmartFace integration. Now I'm using two cameras. This is actually running, everything is running into the SmartFace and NX Witness on my laptop here, which I'm using for this presentation. So as I mentioned, there is no special hardware, special cloud, special server, or some special device needed. It's a simple gaming laptop which I'm using here with my USB camera here, this one, and another IP camera, a regular IP camera here. You can deploy the same thing on an edge device, as I mentioned. You can deploy the same thing in a cloud, so it's really flexible. So I'm using these two cameras here. The way how this integration is done, and I'm going to use NX Witness for everything here, so I demonstrate the flexibility and the possibilities of this NX Witness and SmartFace integration, is that any camera used by NX Witness can be forwarded, or the video stream from any camera used by NX Witness is forwarded into SmartFace. SmartFace does the job and sends the information and the output back to NX Witness. So that's one important element of this integration and the flexibility, that it's not us in this case handling the cameras, it's NX Witness handling the cameras, and whatever NX Witness can handle, it means that we can handle as well. In these two cameras, now you can see my face with some metadata which we send to NX Witness. This is of course customizable. Now in this particular setup, we don't send all the metadata because we extract a lot of information from the faces. We only send a few attributes, a few information into NX Witness, and those are, you can see here now in my screen, there is an estimated age, there is a detected gender. The age is, let's say quite okay, quite accurate. There's a detected gender, which is also accurate. Now it says I'm not wearing a face mask, so the mask status is no mask. If I put my mask on, good. Now it says the mask is present. So the third attribute from the top is the face mask. Now it says mask present. If I take it off, the mask status is no mask again. There's my name, Mate. So it means this comes along with real-time identification as well. We have a watch list now in SmartFace with a few users registered, which I'm going to show in a couple of minutes. So SmartFace also recognizes and identifies my face in this watch list. There is an ID number, there is a watch list ID, and there's a score. Score is basically the confidence of the matching, or the probability that this person is really the one we claim it is. So just a couple of words about the NX integration. So now if I go to the camera settings here, you can see the plugins here. So this creates this is basically the whole NX integration, right? So now I'm using an out-of-the-box NX Witness VMS, which I just installed on my laptop, and I also installed the Innovatrics SmartFace Analytics plugin, which enables me to forward this video stream into SmartFace on a URL, on a port, select all the metadata or the attributes I want to receive, select all the analytics events I would like to use using SmartFace, and I'm ready to go. Once this integration is enabled, you'll get all these faces, all these objects here in your NX Witness client interface, which is basically the SmartFace face recognition output. Of course, once you've set up this integration, you can use your NX Witness to create some analytics events. So now I select analytics events. I want to use this webcam, and I can use the SmartFace events, which is person identified or a known person detected, or basically unknown person detected. I can use these triggers, and I can trigger different. I can use some filters. So I can use the metadata here, with mask, without mask, blacklisted person, whitelisted person, and so on. And then I can trigger some action. So this is a basic usage. I can create a bookmark. I can trigger some alert and so on. This is a basic usage of NX Witness with SmartFace plugin as the video analytics and the face recognition engine. Okay, what I would like to demonstrate here in this screen is basically the accuracy of the engine. So now I have two cameras, one in a frontal view, the second is slightly from a side bottom view. Both cameras are able to recognize, track my face, although this is not an ideal scenario here. They're able to recognize and track and identify my face without mask and with face mask too. So now I'm putting on my face mask. Now my face mask is also only half of my face is visible, but still you can see here in this video stream, SmartFace is still able to identify my face. It still says it's Mate, is the same person with slightly lower score. Of course, that's natural, that's normal, because only the half of my face is visible, so the confidence is always slightly lower. But yes, the face recognition result is still correct, it's still accurate. If the environment is even more challenging, so it's not only a non-frontal view, but it's even a partially covered face. So now I'm going to use my notebook to cover the half of my face. And now look at not only this is the easy one, right? This is the easy one here. This is not the easy one. Now this environment is getting very, very challenging because the view is from the side, from the bottom, and it's a partially covered face. Only less than half of my face is visible now. But still, the face recognition result is there. It still identifies and tracks my face correctly. If this is a vehicle lane and I'm sitting in my car, then obviously many times only the bottom part of my face is visible. So look at this now. On this side camera, only the bottom part of my face is visible, but still the face recognition result is correct. It's still accurate. This is tuned in real life environments, right? So not only like my home office, but outdoor environments with very poor lighting conditions, distant faces from the camera, and so on. So this technology is proven in large-scale deployments. As I mentioned, it's tuned, it's adjusted for these kind of challenging environments. Okay, so let's move on. I'm going to switch now to another view here in my NX Witness. Now I switch to the SmartFace security dashboard. So SmartFace comes with such a dashboard, able to display some of the video streams. This is now not a real-time video stream. This is a recorded video. Basically, what I showed in the previous layout, in the previous view, was the actual NX Witness camera stream screen, let's say. Now this is a built-in SmartFace screen which can be displayed within the NX Witness interface. Now I want to show you this screen as well, not because this is something to replace the VMS. We are not trying to replace the VMS by displaying the screens and the real-time video streams and so on. The reason why I would like to show this is to demonstrate that SmartFace is not only a face recognition engine, it also comes with pedestrian recognition. So now in this video, where my colleagues are walking around in our HQ office, if you notice, when those people show up in the back of the office here, the face is still not visible because of distance, because of they're partially covered, because of resolution, for whatever reason, but the human body is detected, right, in a real time. So the human body is detected even before the face is visible, or even if the face is not visible at all. And we track those pedestrians. And when the face becomes visible, then we detect the face as well and link it to this object, to this pedestrian. By the way, we keep working on the product. So I mean, basically, we are a technology vendor company, so we have to keep improving everything all the time. If we stop improving it for a month, it means we are out of the game, right? Because this is video analytics and face recognition. It's a really fast technology. This industry is evolving very fast. So we keep working on this all the time. It's never finished. Now we are adding more objects. So now we recently added pedestrians, body parts, skeleton analysis, and now we proceed with different object detection engines for vehicles, guns, briefcases, and so on. So we are really moving towards video analytics as such, instead of face recognition only. Okay, let's move to the next part of this demo here. So this is a history view of the SmartFace engine. So whatever you could see here in this in my real-time video and face recognition, and in the previous dashboard with my colleagues walking around, that is available here in this history screen. So basically, you can browse all the previous events, detections, recognitions, everything that happened in SmartFace in the past, right? So here's my colleague. This is now a detected pedestrian. This is here. The face is not detected in this particular frame. The face of this guy was detected here. So here you can already see that, yeah, this is Donald. This is the full frame. This top cropped photo is the cropped face from this full frame, and the bottom photo is the one found in the watch list. So this face was detected, the face was being tracked, and the face was identified. It was found in one of our watch lists. It comes along with all these metadata, as I mentioned. Now let's see one of my faces, if it's there, but now it's full of these. Okay, so this is one of my faces, which I was just trying now. So this is from the side camera, right? This is from the side camera, and this is my watch list item. This is my photo, which is registered in the watch list in the database of SmartFace. So this is the found photo. Every time my face shows up in front of some of the cameras, this photo, along with my registered personal information, name, and so on, is found in the database. Having said that, let's move to the watch list. So SmartFace comes with a management interface for watch list, so you can create different watch. You can create a blacklist, a whitelist. You can create an employees list. You can create basically whatever group of users you want to create. We are using this demo watch list here, and we have a few users. This is my profile. So this is the photo which is found in most of my detection. So every time I show up in front of the camera, this photo is found because this is my master profile photo. And this master profile photo is actually the first photo which was registered in a controlled environment. So we use the mobile device, we use the mobile app to take a selfie. We have a mobile technology for this as well. I took a selfie, I submitted this selfie to SmartFace to register into this watch list, and my profile was created using this photo. However, since that time, I kept using the system over and over again on a daily basis. I was using the system because I kept coming to the office every day. I kept entering the same door, right? I kept showing up in front of the same camera. So what happened over those days or weeks is that SmartFace kept updating my profile. So all these photos which you can see here, you can see that these photos are wild images. Wild image means non-collaborative user, right? This first is not a wild image. This first is a controlled environment, but all the rest are wild images with this little letter A here. A is for auto learn. So all these photos were added to my profile by SmartFace automatically while I was using the system. While I walked through a turnstile, I showed up in front of some of the CCTV camera, my face was detected, and that face, not all of them, but it goes through some selection, of course. Some of those faces were added to my profile with face mask, without face mask, partially visible faces, faces from the side, faces from a frontal view. So that's how SmartFace learned to recognize my face with an exceptional accuracy, because it kept learning how my face looks in different environments, in different point of time, in different conditions. Right? So this is how the auto learn keeps improving the accuracy of the system continuously. Okay, so now we pretty much covered a few use cases here. So this basic NX integration with the real-time metadata integration, the alerts, the analytics events, this is our plugin on top of the basic SmartFace platform for surveillance and public security. which is a quite traditional use case, right? So you use your VMS, you use a bunch of cameras, you extend your VMS with the SmartFace plugin, and you use the face recognition and the video analytics, including pedestrian recognition, result in your VMS to create analytics events, to create bookmarks, to start the recording, and so on. So this is the public security and surveillance plugin or use case. Now let's talk about a different plugin. So as I mentioned, now we're talking about one instance of SmartFace. SmartFace goes with the surveillance plugin, so you use it in your VMS. And now the same instance comes with an access control plugin as well. So now we are going to move to the access control use case. Now let's imagine that this camera here, this camera is not just a regular CCTV camera. This camera is an access control camera. This camera is sitting on one of my turnstiles. This camera is hanging on the wall next to the door of my office room. Or this is a built-in camera of a tablet kind of device sitting on my turnstile, right? So what happens here is that this camera is using, as I mentioned, exactly the same engine, exactly the same face recognition technology as a CCTV camera, of course, which means we can implement a very, very powerful access control solution using this camera. As I mentioned, we call this access control solution seamless access control because I don't really have to look into the camera. I don't have to wait and stop at this camera. I don't have to slow down at the turnstile. I just keep walking. As I keep walking, the camera detects my face, recognizes my face, and triggers some action when I get close enough, because it also detects the distance, right? So when it captures my face, but it's too close or it's too far from the camera, it just identifies my face. Yeah, this is Mate. He can enter, but he's still too far. And then as I'm getting closer to the camera or the turnstile, when I'm close enough and the decision is already made, the decision says this is Mate. Mate can enter. We trigger an action. When an action is triggered, that action is also displayed on an access control dashboard, which is a different dashboard, custom dashboard for this use case, which is built for, let's say, security personnel or receptionist sitting at the front desk, right? So what we can see here, this is the access control camera. So just you can see the camera angle, what the camera can see. And this dashboard here is our access control dashboard. For access control, we have some rules. Number one, to allow somebody to enter the building, must be a registered person, must be permitted to enter the facility. Number two, of course, this person must be a real person. It cannot be a spoof. It cannot be a presentation attack. We cannot open the door for anybody holding a picture of somebody who is registered. And number three, something more specific for these last few months or almost 2 years, this person has to wear a face mask, let's say. This is still a requirement in many countries, and maybe it's going to stay with us in some regions for some while. So let's set up these three rules: must be registered, cannot be a spoof, and it has to wear a face mask, right? So if I play by the rules, I put my face mask on, and I try to enter this building, this is what the security guy will see. Now I'm not here. Now I'm going to approach this turnstile. I'm going to approach this camera. I show up in front of the camera. When I show up in front of the camera, a passage is recorded. This passage means the security guy can see that the door was opened for him, right? So now again, I'm not here. I'm going to approach my camera. I'm going to try to close the turnstile. As I get close enough, a passage is recorded. Passage means this guy could enter this building. The turnstile was opened automatically. This is a happy result. This is a happy scenario. But what happens if I try to enter this building like this? If I try to enter this building, of course I have to get out and come back again. If I try to enter the building like this, the door doesn't open. It says no mask. All right? It says no mask. If I put my mask on, a recent passage will be recorded. I was just putting my mask on, it was already accepted. If I pull my mask down, it says no mask, the door doesn't open. And this is shown to the security person. So, of course, we have to make sure that nobody enters the building if not registered, not wearing a mask, let's say, or even worse, trying to cheat. So what if I'm not using my own face, but I'm trying to cheat like this? I'm holding a cell phone or a printed photo of somebody else, or even myself, in front of the camera. This is a photo of myself wearing a mask. So this person is now registered. This person is wearing a mask, but this person is not real. This person is a spoof, it's a fake, right? If I show my real face, yeah, of course, you're cool, you're a real guy, you're registered, but you're not wearing a mask, right? Now I'm registered wearing a mask, but I'm a fraud, right? So this is how smooth it is, and this is how all these events are shown in the access control dashboard, shown to the receptionist, let's say, in a real time. And of course, if somebody's playing by the rules, so I put my mask on, I'm registered, I'm real, and I'm wearing the mask, then just a passage is recorded here, and the door is open. The last screen we are going to show is for exactly the same use case. So now let's stay in the same lobby, right? So this is my access control camera sitting on the turnstile in the lobby. This access control camera is connected to NX Witness. NX Witness is connected to SmartFace. SmartFace is connected to the barrier. So SmartFace is opening, closing the door. And in the meantime, it displays the corresponding notification for the security person or the receptionist. But now we are going to take a look at exactly the same scenario, but not from the receptionist perspective, but from the user perspective. So now I'm going to switch this screen, which is the back-end screen. I'm going to switch it to a front-end screen. So now still here in this screen, you can see here you can see the camera angle, which is the same camera, this access control camera. But this user interface, which you can see here, this is a feedback screen. So this is a screen sitting on the turnstile. This screen is giving me some feedback, right? Now, of course, my face is recognized. Hi, welcome, Mate. Please put on your mask before you enter this building, because this is not cool. You cannot enter this building like this. Okay, no problem. I put on my mask. Hey, welcome, Mate. Please enter. The door is open, right? If I try to open without a mask, no, this is not cool. You cannot enter like this. If I put my mask on, yes, welcome, Mate, and the door is open. So now on the background, of course, these events go with hardware level integration as well. Now I cannot enter, or even worse, I try to cheat. Passage is not allowed. So this says passage not allowed. You're not a real person. Now it says, yeah, of course you're a real person. I know you, but you have to put your mask on. Okay, no problem. I put my mask on. Now my mask is on. Okay, welcome. Please enter. So this is how smooth it is. This is how it responds to different events. It evaluates the identity of the person, the mask, face mask status of the person, the liveness or the genuinity of this person in a real time. And in a real time, it triggers the notification on the front end feedback screen, the notification on the back end access control dashboard for the receptionist or for the security guy. And it also triggers the action to open the door or close the door, or to handle the physical barrier of the access control system. Of course, all these features or all these information for each event are included in the surveillance plugin as well. So when it comes to public security, surveillance, CCTV, video analytics, all these metadata are pushed back to NX Witness as well. So everything is available in the SmartFace platform and NX Witness. So you can use all these features from both ends. You can integrate your system with SmartFace. You can integrate with NX Witness, or you can just use the NX Witness interface with all these smart things inside. This is it in a nutshell. Thank you very much. Matt, over to you. And if there are any questions, yeah, feel free to raise those. I'll be happy to answer. Thank you.
There haven't been any questions come in. Are there any questions from any of the people? Nope. If you need Innovatrics details, feel free to reach out to me. I can pass them on to you. You can get licenses and bits and pieces and demos and all that sort of stuff set up, whatever you want to do. Mate will be able to help you out. So yeah, any questions you have, send them through to me and I'll forward them on to Innovatrics. If you just want their details, yep, send them through to me as well and I'll forward it on. Thanks for your time, mate. And we'll speak to you all again soon.
Thanks, Matt. Thanks for having me.
Thanks, guys. Have a good day.